This is Unit 1, Lesson 9, Polynomial Operations. Okay, we're going to start out with a quick review of combining like terms. Take a look at this expression. You can see that we have a number of different terms that are combined with adding and subtracting, and we want to be able to simplify by combining any that are like. That means they have the same variable raised to the same exponent. So I'm going to go through and look for any that are alike, and we've got a negative 4x squared and a positive 1x squared, so those can combine and make negative 3x squared. And then I've got a 2x and a 3x and a 7x. Those three are also like terms. We can combine those and get 12x. And then we've got a constant of 12 and a constant of negative 5, and we can combine those and get 7. So we've got a resulting expression that is a simplification of what we started with. Adding polynomials is very much like combining like terms, but we just need to take a couple more things into account. First of all, what we're saying here is we are adding the entire first polynomial along with the entire second polynomial. So when we go to simplify, we first have to remove our parentheses. So you can see there's nothing going on inside this first polynomial except the combining with adding and subtracting. There's no multiplying ahead of it, and so we can just simply remove that from the parentheses and rewrite it x squared plus 9x minus 8. Now, we want to think about what operation we're doing to the second polynomial. So we're going to add everything that's in the second polynomial. So I want to add 2x squared, and then I'm going to add negative 4x, and I'm going to write that as minus 4x because that's adding a negative 4x. I'm going to add negative 5, so I'm going to write that as negative 5. So really it appears that we've just rewritten everything without the parentheses, which is essentially what we do when we're adding. But I want you to think of it in terms of adding every single term in the second polynomial to that first one. So now we can go ahead and combine like terms. I've got an x squared and a 2x squared, which gives me 3x squared. And then I've got a 9x and a negative 4x, which combines to make positive 5x. And then I've got a negative 8 and a negative 5, which makes negative 13. Now you'll notice that I'm doing these in a particular order. This is standard form, where the exponents are placed in decreasing order. And we're going to talk a little bit more specifically about that in a few minutes. Subtracting polynomials is not that much different. We're starting with our first polynomial, and so we can rewrite it exactly as we see it: 5x squared minus 8x plus 10. And now we see that we're going to be subtracting that second polynomial. Well, that means we need to subtract all of the terms inside. So we need to apply that subtraction to each of those terms. You can think of it as distributing, because that's in fact what it is. We're distributing the subtraction. So I'm going to subtract 6x, and so write minus 6x. And then I'm going to subtract a negative 2x squared. So subtracting a negative 2x squared actually comes out to be adding positive 2x squared. And then we're going to subtract a 3, so I'm going to write minus 3. So it's important when you are subtracting that you have to distribute that subtraction to all of the terms in that second polynomial. Now we'll go ahead and combine like terms. 5x squared and 2x squared makes 7x squared. Minus 8x minus 6x is minus 14x. And plus 10 minus 3 is plus 7. Again, in standard form. That's important. All right, multiplying polynomials is something that you've done before. We're going to start with one that should look familiar because it's distributing. You can see that we're multiplying our large polynomial in the parentheses times 5x. So it means everything inside needs to be multiplied by 5x. So we need to multiply 5x times 2x squared. I'm going to multiply the coefficients. 5 times 2 to get 10. X times x squared is x to the third. Now I need to multiply 5x times the next term. 5x times negative 4x is negative 20x squared. Then I need to multiply 5x times 3. 5x times 3 is plus 15x. You can see that we don't have any like terms. We have an x to the third, x squared, and x. None of those are alike, so we are finished. Double checking that we're in standard form. The exponents are in decreasing order, 3, 2, and 1, so we're good to go. All right, now this is a little bit different. It's still multiplying polynomials, and you can see that there are 2 terms in our first polynomial instead of just 1, and that's what makes things different about this lesson. So we still have a polynomial we're going to multiply, 6x minus 5, but now we have 2 terms that need to be multiplied times everything in the second one. So I'm going to start with the x, and I'm going to say x times 6x gives me 6x squared, and x times negative 5 gives me negative 5x. But now we also have a 10 in that first polynomial, so we have to multiply that times everything in the second polynomial as well. So I need to do 10 times 6x gives me positive 60x, and then I need to do 10 times negative 5, that gives me negative 50. Now taking a look at that, I can see that I have some like terms, negative 5x and plus 60x. So we're going to get 6x squared. Combine those like terms, we get plus 55x, and then we have minus 50. So now our multiplication is complete, along with our simplification of combining those like terms. All right, I want you to pay attention to the operation. It's very easy to visually miss what's going on. So pay close attention to what's in between the parentheses in the middle. Is it adding? Is it multiplying? Is it subtracting? It's easy for kids to make a mistake simply because they think it's a multiplying problem when in fact it's an adding problem. So I'd like you to pause the video and try these 3 problems. Come on back when you're ready. All right. Here are the results for each of those examples. You can see that I removed the parentheses by either adding, subtracting, or multiplying, and then I combined like terms. So check your answers. If they're incorrect, pause the video and see where you went wrong. If they're right, go ahead and proceed. Okay, we're going to be modeling polynomial operations like we just did, adding, subtracting, multiplying, using something called algebra tiles. For a number of people who are very visually oriented, these are a great way to help them see the differences among the variables. When we're using variables, it's fairly abstract, and that's tough for some people to process, so it's easy for them if they're processing something physical. For other people, they see these algebra tiles and it just makes them more confused. So we'd like to use these tiles for the people that it helps, but we have to also acknowledge the fact that they are used on the SOL. These visual images are on the SOL. So we need everybody to practice with them a little bit so that they are prepared to use them on the SOL. So you can see these tiles are representing some variables and also a constant. So this little one right here is representing the constant 1. So if we had 1 tile, it would be a 1. If we had 3 tiles, it would represent the constant 3, etc. Okay, and then we have 2 different tiles that are different lengths representing the variables x and y. So here is an x tile, and here is a y tile. You can see the dimension is 1 by this certain length called x, and 1 by the length called y. And then we have 2 other tiles that represent the variable squared. X squared, you can see, is the length of x on one side and the x on the other side. That gives us x squared. And the y squared tile is y by y in dimension. We also use shaded versions of them to represent negative values. So algebra tiles can model a polynomial expression. So you can see here an expression. This is an x squared tile, and an x squared tile, and an x squared tile, and an x squared tile. So we have 4x squared. Here we have an x tile, but it's shaded, so we know it's negative x. And we have 3 of those, so that represents negative 3x. And then we have 1, 2, 3, 4, 5, 6, 7 unit tiles, so that's plus 7. So these tiles model the expression 4x squared minus 3x plus 7. We can also model polynomial addition, which is like combining like terms. So you can see we have some expressions. Why don't you pause the video and write out the expressions that you see here. We have a polynomial added to another polynomial equals a resulting added polynomial. So go ahead and pause the video and write out what you see. So our first polynomial here is going to be 2x squared plus 3x plus 3. We're going to add to that negative x squared plus 2x plus 1. That results in the polynomial x squared plus 5x plus 4. So this is a nice way to visualize what's going on with something that's fairly abstract. It might help you. We can also model multiplication, which is distribution. This is definitely more confusing for people who are confused by these tiles. Just kind of bear with us. You can see that we have two expressions being multiplied, x plus 4 times 2x. We have two x's right here, and we have an x and 4 unit digits here. So our multiplication is going to show the x plus 4 times 2x. I probably should have written it the other way, so I'm going to do that. 2x times x plus 4, because we're a little bit more familiar with it written that way. So we can see when we distribute what we would get. You can see that it's modeled when we multiply x times x, it gives us x squared. And again, here's an x times x squared gives us x squared. When we multiply this x over here times 1, it's giving us an x. And x times 1 gives us an x. And x times 1 gives us an x. X times 1 gives us an x. Same thing is happening down here, more x's. So our result is that we have 2x squareds and we have 8 x's. Well, let's see what happens when we distribute. 2x times x is 2x squared, and 2x times 4 is 8x. So it's a nice way to visualize what's happening in that distribution. Here's another one. Take a moment to pause the video and see if you can write the expression that's resulted when we multiply 2x plus 3 times x plus 3. So try not to do it just by distributing. Try and do it based on what you see in the figure. Pause the video and then give it a shot. Okay, you can see that we have two x squared tiles. So we're going to have 2x squared as one of our terms. And then we have some x's, 6 of them down here. But we also have 3 of them over here. They're sideways. Or actually, those are vertical. The other ones are sideways, or however we want to think about it. But anyway, we have a total of 9. So we have plus 9 x's. And then we have 2, 3, 4, 5, 6, 7, 8, 9 units, so a constant of 9. And you can see that if you did the distribution, that's in fact what we would get. If we did that, 2x plus 3 times x plus 3. Let's take a look what would happen. We'd say 2x times x is 2x squared. When I multiply 2x times 3, I would get plus 6x. When I multiply 3 times x, I would get 3x, and when I multiplied 3 times 3, I'd get 9. So you can see the 2x squared is represented here. And the 9 is represented here. And then you can see that we have, let's get another color going on here. We have a 6x term that eventually got combined with a 3x term to make 9x. But you can see that the 6x ends up over here and the 3x ends up over here. And that's what's actually shown in this visual model, that we have two different spots of getting x terms, and we just combine them at the end, put them all together when we have a simplified expression. All right, we need to talk about standard form. We've done this before, so this is a review. Basically, we need to add the exponents in each term to determine the degree of the term. We order the terms from the highest to lowest degree, and if there's a tie, we use alphabetical order. So Here is an expression with two terms. So the degree of this term here is going to be 6 because we're adding the 4 and the 2 exponents to get a degree of 6. In this term, there's no exponent for the y, but we know it's a 1, so we're adding a 3 and a 1 to get a degree of 4. It's the sum of the exponents. You look only at the exponents to determine the degree. Even if there's nothing there, you know it's a 1, right? This 7, nothing to do with it. Has nothing to do with the degree. The coefficient does not have anything to do with the degree. All right, so let's take a look. Standard form. Here's an example of standard form. Our terms are decreasing degree. This is a term has a degree of 2. This has a degree of 1. This has a degree of 0. This isn't standard form because you can see the 1 is coming before the 2 in terms of the degree. And so that's not standard form. In this next example, we have another example of standard form. These two both have a degree of 2, and so you choose which one comes first because of alphabetical order. So the x term would come before the y term. These each have a degree of 1, so the x term comes before the y term, alphabetical order. These are not in standard form because you can see this has a degree of 2, this has a degree of 1, 2, and 1, so that's not the proper order. Now the last one, this is in standard form. This term has a degree of 9. This has a degree of 4, 5, 6, 7. This has a degree of 5. This one's not standard form because the 5 is coming first, and then the 7, and then the 9. All right, what happens if there's a tie? You can see the degree of this. It's 3, 4, 5, 6, 7. The degree of this, including that C to the first, is 7. And the degree of this is 7. So we've got a tie. Only when there's a tie in degree do we use alphabetical order. So you think of the expression as written out in expanded form. This would be A, B, B, C, C. This one would be A, B, B, C. And this is A, C, 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 C. So the way to decide is if you looked at these and they were words in the dictionary, you look and see which one would come first. So this one has 4 A's, so in standard form we would write A to the 4th B squared C. And then the next one that would come next is this one, so we would write plus A to the 3rd B squared C squared, and then that last guy. And that's how we deal with the tie. All right. I think that's it. Oh, look, I had that little thing to pop up and I didn't do it. All right, your homework is worksheet 1. Please complete that worksheet before you come to class tomorrow. Check and correct as normal. Enjoy.